Hello everyone. I'm glad to present our work, Temporally Consistent Online Depth Estimation in Dynamic Scenes. Depth estimation is important for tasks such as mixed reality, where the users can view the scenes in 3D for better perceptual understanding. However, this is only part of the story, as what we really need is temporally consistent, online, dynamic depth estimation to accommodate all the use cases. And the consistency is the key because otherwise the jitters in reconstruction will severely corrupt the perceptual quality as highlighted here in red. Unfortunately, this task is very challenging for two reasons. First is the online requirement. For live stream videos, we do not have future information, and thus we can only rely on past observations to improve consistency. Secondly, the dynamics of the scene. Due to the camera motion, object motion, and object deformation, improving consistency needs to resolve many ambiguities compared to a static scene. Therefore, we present consistent online dynamic depth framework, or COD in short, to stabilize depth estimation for video use cases. Below, we show a comparison between per frame network on the left and the COD on the right. And the COD not only stabilizes the static background, such as the wall, but also the dynamic foreground object, such as the cat. COD assumes no scene prior and thus works for different environments. In the driving scenes, we can see that the COD improves the stability of background and foreground simultaneously. COD further applies in medical images, where the patient anatomies are observed. How does COD work? COD builds upon stereo depth networks, which extract per frame depth and features at each time point. For consistency, we introduce two additions. First is the motion network. The motion network takes estimates from both the current and previous time points as input to regress per pixel 3D motion. Therefore, we can back project the observations from previous time point, use the 3D motion to align the past observation to the current time point, and project it to generate the aligned estimate. This process is done via differentiable rendering for end-to-end optimization. This process is not only online, which requires only past estimate, but also is able to accommodate all kinds of dynamics. We then introduce a fusion network, which regresses per pixel weights given the aligned estimates. We then use the learned fusion weights to aggregate the estimates, generating temporally consistent depth. COD runs for the entire video sequence. After generating consistent depth for the first frame, the result is cached for the next frame. This process iterates until the end of the video. COD outperforms per frame model by up to 31% for temporal consistency and performs on par in terms of depth accuracy. For more details of our work, please visit poster session 7C and check out our project page below.